Assalamualaikum and good day to all of you. In this video, I will explain about the causality and stability based on ROC of Z transform. A discrete time LTI system is causal if and only if, we see the first point here. The ROC is the exterior of a circle outside the outermost pole. What is the meaning of this first point? We assume that we have a pole Z bigger than 2, and we have another pole that is Z bigger than 3. So we want to find the common ROC for these two poles. Draw these two circles. This is at point 2, and the second circle is at 3, radius of 3. So we know that Z bigger than 2 is here. And then we have Z bigger than 3, which is bigger than outermost pole. So which one is overlap? The overlap part is Z bigger than 3. So this is the common poles, that we will consider. So this is 3. This is the outermost pole. 3 is the outermost poles, and then the ROC is the exterior of a circle, which is bigger than, the ROC is bigger than the outermost pole. This is the meaning of the first point here. So the system is considered as causal system. The key point here is outermost pole and exterior of a circle. What if I give you an example? What if the ROC is between 2 and 3? Is it considered as causal system or not? For example, we have two circles here, 2 and 3, and the ROC is between these poles, 2 and 3. Is it considered as causal system? No, it is unsatisfied the first point here, which is exterior of a circle. This is inside the outermost pole, less than 3. What if the poles is less than 3 and the other poles is less than 2? So the overlap part is here. This is the overlap part, the common ROC that we consider as ROC for the system. So is it considered as causal system? No, actually it is not a causal system. It is unsatisfied this condition. The second point here is, if Hz is expressed as ratio of polynomial in Z, the order of numerator cannot be greater than order of the denominator. When we have a system, LTI system, we can directly observe the system, and we can know that whether the system is causal or not based on the order of numerator and denominator. Okay, for example, if you have Hz equal to Z over Z plus 1, Z minus 1. So the numerator order is less than denominator. So the system is considered as causal system. Okay, now we go to the stable system. An LTI system is stable if the first point here is its system function Hz includes the unit circle. What is unit circle? So the unit circles means that the ROC, okay, we have ROC. This is the unit circle when radius is equal to 1. So unit circles means that the poles that includes in this function Hz should include, the ROC should include the unit circle, so that it will consider as stable LTI system. Okay, so I will give you an example. Okay, so if we have, for example, we have Hz equal to Z over Z minus 1 over 2, Z minus 1 over 3. Okay, we consider this system is at the right-sided signal. So we want to find the poles, the first poles and the second poles. So Z minus 1 over 2 equal to 0. Z bigger than, because it is at the right-sided signal, it is bigger than 1 over 2. What about the second poles? So we have Z minus 1 over 3 equal to 0. Z bigger than 1 over 3. So now I will draw both of these poles inside the Z plane here. So we have 1 over 2. And the Z here is bigger than 1 over 2. So I will draw like this. The second pole is Z bigger than 1 over 3. So I will draw 1 over 3 here. 1 over 3. We know that Z is bigger than 1 over 3. So I will draw like this. Okay. So the common ROC, we consider it at the overlap part. Which one is at the overlap part? Is when bigger than 1 over 2. That is bigger than 1 over 2. The ROC is this one. Okay. So, okay, I will draw it again so you can see it clearly. We have unit circle. Unit circle, we need to draw unit circle as reference, whether it is the ROC includes the unit circle or not. So we need to draw unit circle as a reference. Now we know that the common ROC here is bigger 1 over 2. Okay, I will draw 1 over 2 here. So the ROC is outside 1 over 2. Sorry, this is only Z bigger than 1 over 2. So the ROC, the common ROC is Z bigger than 1 over 2. So I will draw it again so you can see it clearly. So the ROC is bigger than 1 over 2. Is it the ROC includes the unit circle? Here. Yes, it is include the unit circle, which is ROC equal to 1. So the system here is a stable system because of the ROC include the unit circle. The second point here is a causal LTI system is stable if and only if all the poles of HZ lies inside the unit circle. We know that causal LTI system is when the ROC is lies outside the outermost pole. For example, we have two circles. The ROC is lies outside the outermost poles. Okay. This system is causal. But if you want a causal system is stable, the poles here, I don't write the number here. Okay. The poles here must lies inside the unit circle. You know that unit circles is at radius 1. Okay. So if these poles, for example, this is 1 over 2 and this is 1 over 3. If the poles is inside the unit circles, so the ROC is includes the unit circle. See here? Okay. This is the ROC. The ROC will include the unit circle. If the causal system with poles of HZ inside the unit circle. This is inside the unit circle, 1 over 2 and 1 over 3. So causal system is outside the outermost poles. Okay, so include the unit circle. So this system is causal system and also stable system. Okay, now I will show you example 1 of causality and stability. The question asks you to check the stability and causality of a system with xn equal to 1 over 2 to the power of n un plus 3 to the power of negative n u negative n negative 1. Okay, so this is the question. First, you need to change it to the xz expression. Okay, so you know that here is z over z minus 1 over 2. Please refer to the table of Z transform pairs. And the second one is 1 over 3 to the power of n u negative n negative 1 is equal to is same is Z over Z minus 1 over 3. Okay, now we need to find the poles. Okay. The first poles here, this is the second poles. So the first poles is Z minus 1 over 2 equal to 0. Z bigger than 1 over 2. And the second poles is Z minus 1 over 3 equal to 0. Z less than 1 over 3. Why this is less than? Because we refer to the signal which is at the left side signal. So the sign here is less than. And for this one, this is positive end, which is the signal lies at the right side. So this sign is bigger than 1 over 2. So first we need to draw the unit circle. This is not the poles, this is just a reference for you to know whether the system is stable or not. Okay, now I will draw the poles. Okay, so Z bigger than 1 over 2. 1 over 2 is inside here. So 1 over 2. Bigger than means that outside the 1 over 2. And then we have 1 over 3 here. 1 over 3 is inside the circle inside 1 over 2. And it is less than, which is 1 less than 1 over 3. So this system is actually don't have any common ROC because no overlap ROC here between these two poles. So the system is unstable and non-causal. So we cannot consider this ROC because don't have any common ROC. Okay, for example number 2, the question asks you to check the stability and causality of a system with xn equal to 1 over 2n un plus 3 to the power of negative n un. Okay, so we change 3 to the power of negative n to 1 over 3 to the power of n. And then find the find the z transform. So you will get for this term you will get z divided by z minus 1 over 2 plus z divided by z over z minus 1 over 3. So we need to find these two poles, the first poles and the second poles. Z minus 1 over 2 equal to 0. Z minus 1 over 3 equal to 0. So we know that the signal, both of the signals is UN signal, is at the right-sided signal. So automatically we know that this sign is greater than. Okay, now I will show you. This is the unit circles on the Z plane. Okay, first I will draw 1 over 2. 1 over 2 greater. Greater is over here. And then we have 1 over 3. 1 over 3 greater, also greater than. So I will draw it here. Okay, which one is overlap? Overlap at Z greater than 1 over 2. So is it include the unit circle? The ROC include the unit circle? Yes, it is include. The ROC include the unit circle, which is at 1 here. So it is actually stable system. Is it causal system? Okay, if we see here, the ROC is lies at the outside outermost poles. Outermost poles is 1 over 2, not 1 over 3. It's outside. So the ROC lies outside the outermost poles. So it is causal system. Okay, this is the answer. Now we go to example 3. Okay, the question is same with the previous examples, which is you need to check for stability and causality of a system with response given xn 1 over 3 to the power of n un plus 2 to the power of n u negative n negative 1. So we need to change it to Z transform expression. So you will get from here, you will get Z over Z minus 1 over 3 minus Z over Z minus 2. So we have two poles here. So this is the first pole, second pole. Z minus 1 over 3 equal to 0. So we know that this signal is UN, positive n. So bigger Z, bigger than 1 over 3. And the second signal is U, negative n, negative 1. So it is negative n, left-sided signal. So the sign is less than 2. So I will draw the poles. So the first, the red color circle here is unit circle because it lies on 1. This is not considered as the poles. This is just a reference to know whether the system is stable or not. Okay, so I will draw 1 over 3 first. 1 over 3. Okay, Z bigger than 1 over 3. So the area is outside 1 over 3. Now we have Z less than 2. So 2 is here. I will draw it. 2. Okay. So Z less than 2. Less than 2 means that it is at this area. Okay. Okay, which one is overlap? The overlap part is Z between 1 over 3 and 2. This is the common ROC. Okay, we want to know whether the system is stable or not. So we know that between this common ROC is include unit circle, right? Okay, so unit circle here. Okay, include the unit circle, so that means it is stable. Okay, what about causality? Is it causal system or not? Okay. Okay, we know that the outermost poles is 2, but it is not lies outside the 2, the poles 2. The ROC is not lies outside the this outermost poles. So it is considered as uncausal system.